Hello everybody, this video clip is for chapter 1, okay, and this is the third clip of chapter 1 for a calculus for business 2. All right, previously what we have learned is about the row operations, okay, which you got three kind of operation. So the first one is that you can switch the ith row and the jth row, okay, and then you use this kind of notation. The second one is that you can change the ith row by multiply the whole row with a constant k, and this constant must be non-zero. The last one that you use a lot, this actually is the one that you use to eliminate, okay. So it is you are going to change your ri by keep your ri here, and then you add the k times rj, okay. So this means that the only row that it change is the ith row, and your jth row has will remain the same, okay. You just borrow this rj, okay, with k times, okay, to change your ri, okay, but your j row are the same. Of course this k must be non-zero. And we also introduced the so-called reduced matrix, and the reduced matrix is the one that you see a lot of 1 and 0, okay. So it means that as you look at each of the row, okay, if you see a non-zero row like this, you need to look at the first non-zero element. It must be 1, and the rest in that column must be 0. If you look at your second row, you look for the first non-zero element, okay, the rest must be all 0. You look at the third row, you find the first non-zero element right there must be 1, and then the rest in this column must be 0. And then if you have all 0 element in the row, it must be at the bottom. And your 1, as you going down, it must be on the right of each other, okay. As you go downward, it must be on the right, okay, of the one previously. So today we are going to go further into the system of a linear equations, which actually we did mention before, okay. But today, for this clip, we are going to make it more general, okay. Here you got m equations. You see the first equation indicated by C1, the second equation by C2, and then the last equation by Cm. So you got m equations, so basically m row, and then you have n unknowns. So you have x1 as the first unknown here, your x2 as the second unknown, etc. up to your x sub n, which is your last unknown, or the nth unknown, okay, that you've got. So as we mentioned previously, that for your first, for the coefficient of your x1, you can just make it into your first row of the coefficient matrix. Remember this one, coefficient matrix, right? Okay. And then your second, the coefficient of your second unknown can be your second row, and of course the coefficient of your last unknown, it can be your last column right here. And then you are going to multiply with a variable matrix, okay, and this variable matrix will order from x sub 1, x sub 2, etc. to x sub n, and here is all your right hand side coefficient, constant, c sub 1, c sub 2, etc. to c sub m, okay. And as we told you that usually, because all the variable has nothing to do as you calculate or as you change all the system, okay, by using a row operation. So we are going to ignore the variable matrix, and then we are going to attach your coefficient with your constant matrix on the right together, and separate it by this vertical line right here, and this one is so called the augmented matrix. Okay, the augmented matrix, and they got a special name. The first one is so called a homogeneous. Okay, a homogeneous. For homogeneous, I mean this one, it means that your C, okay, or the constant matrix right here, or the C, okay, on your right hand side are 0. Okay, it must be each and every one of them. Then if the system got your right hand side equals to 0, we call a homogeneous. You see, homo is mean single, genus it means type. So you got single type by, I mean a single, each and everything are equals to a single value 0. And of course, I mean, if one of them, okay, at least one of them is not a 0, then we call non-homogeneous. Okay, so it's not the same type. Okay, for example, here on your right hand side they are all 0, so this one is homogeneous. And if your right hand side, if you got like one of them that is not a 0, then it is a non-homogeneous. Okay, and as you can see, if you take a look carefully, if your x, your y, your z, if they are all 0, what happened? Then, I mean, your left hand side vanish, right? So it means that it will equals to 0. This one as well, it will equals to 0. This one also, it will equals to 0. So it means that the homogeneous system always have a solution. Okay, always have a solution, and this one is called a trivial solution, because I mean, if all the variable equals to 0, this is called trivial solution, or the 0 solution. All right, this is one of the solution that everybody can think of, but maybe it may be that you can find some other non-zero solution as well. Okay, that we'll call a non-trivial solution. Okay, so this one, a trivial solution, refer to all 0 solution like this. So we will have some theorem saying that if your A is a reduced coefficient matrix, okay, so this one is only a coefficient, all right, is a reduced coefficient matrix, okay, of a homogeneous system. It has to be a homogeneous of m equations, n unknowns, okay, and your A contain exactly k non-zero row, then if your k is less than, strictly less than n, the system will has infinitely many solutions. Okay, infinitely many solutions. But if your k is exactly the same as your n, then the system has a unique solution, and that unique solution, of course, must be, okay, it must be that trivial solution. What is it? Everything, I mean, each and everything are all 0. Okay. So this one, okay, I mean, when is this one happen? When your, I mean, how can your k less than the n, okay, your non-zero row will less than a number of unknown, okay. Usually it will occur, okay, whenever your linear equation, okay, has a fewer equations than the unknown, okay, then it always, I mean, this one always happen. And if this one happen, then it means that your homogeneous system has infinitely many solution, okay, has infinitely many solution. This one has to be homogeneous. All right, so for example, this one is homogeneous, right? Because here, I mean, don't forget that if you write like this is the augmented matrix. Here is the coefficient, okay, there is your right hand side, which is a constant matrix, okay, and this one, the constant on the right hand side, they are all 0. And you know that here you got 3 rows, so it means that you got 3 equations, okay, and you got 3 columns on your coefficient. So here is the coefficient of x, coefficient of y, and the coefficient of z. So you got 3 unknowns, okay, 3 unknowns. And right here your non-zero row, okay, here is one of them. This one is non-zero row. Here is also a non-zero row, and there is also a non-zero row. So it means that you got 3 non-zero row, and your non-zero row and your number of unknown are the same. Then from the theorem, okay, from the second part of the theorem, it says that you don't really need to solve it. It's already known that you have a trivial solution. X, y, and z, they are all equals to 0. Okay, how about this one? Of course, you still have 3 equations, right? For your second one, you still have 3 equations. However, for the non-zero row, you have only 2, okay, and it less than a number of unknown, which is 3, okay, strictly less than. Then it means that you have this system contain infinitely many solutions. And what is that solution? This is for your variable x, this was for your variable y, and that for your variable z. So it means that this one is a coefficient, right, of the x. So it is x equals to 0. This was a coefficient for the y, so it means that y also 0. And there's no z appear. So it means that this one, your x and your y are fixed, and your z can be any real number that you can think of. Okay, for example, 0, 0, negative 1 can be one of your solution of the system, or 0, 0, 500 can also be another solution of your system. And of course, don't forget that this one is also one of the solution of your system as well, but you also have a non-zero solution. Okay, how about this? Okay, how about the last example? This last example, now you have your variable x, y, z, and w. So you have 4 unknowns. Then you have, 1 non-zero, 2 non-zero, 3 non-zero. So you have 3 non-zero row, and 3 of course is strictly less than 4. So again, from the first part of your theorem, it says that this system, because don't forget that you really need to check that it is homogeneous, okay, in order to use the theorem, you need to know that it is, your right hand side must be all 0. This one will have infinitely many solutions. Okay, well, what kind of solution that you can think of? Here is your x, right? So you have your x and your y. This is your first equation, must be 0. There is your z, also must be 0. There is your w, is 0 as well. Okay, so this means that the solution will be in terms of x, and your y is a what? Your y is a minus x, and then the w, the z and the w fixed to be 0. Okay, so the solution depends on the value of x. For example, if we fixed your x to be 5, so you have 5, negative 5, 0, and 0 as one of your solution to this system. Or you can think of negative 1, 1, 0, 0. Okay, because if your x is negative 1, then your negative x becomes 1, right? So this one also the solution to the system as well. Okay, so the solution will be the x and the y that as you add that it equals to 0, and your z and your w fixed to be 0. Okay, now if you look at this example, let's look at this example. This one is not, so at the beginning this is not a reduced matrix. Okay, this is not a reduced matrix, even though here it is homogeneous, right? It is homogeneous. So if you want to determine like whether they got a unique solution, trivial, or they has infinitely many solution, you need to change, okay, the non-reduced matrix into a reduced matrix. Okay, and because I mean the right hand side it is the all 0, and in the theorem it says that, I mean, you just look at the coefficient matrix. Okay, you don't need to look at the constant matrix. So what you need to do is to look at the coefficient, which is a 1, 2, and a 1 here. So here is your first row, and the -2, -1, and the 1 for your y. This is your second row, second column. This is your first column, sorry. And this is 1, 5, and 4. It will be your third column. Okay, so what is it that you do? You remember what we did previously. You are going to sweep by column. It's okay, sweep by column. So look at the first column. As you look at the first column, you need to look at the first position of your first column, and it must be 1, and it's already 1, so you are okay. Then you are going to get rid of 2 and 1 here. How you are going to get rid of the 2 and the 1? Okay, how are you going to get rid of these 2? You are going to use your R1, okay, as a common row that you are going to use it to change. Okay, so it means that your R1 will be fixed. Okay, so the thing that will change will be only your R2 and R3, and your R2, okay, you put it here, and you get rid of your 2 here by using the opposite number multiplied by your R1. Okay, so the opposite of your 2 is -2, okay, and multiply by R1, and then add your R2. So the -2 multiply here will becomes -2, 4, and -2, and then as you add all these to your second row, you are going to have a 0, a 3, and a 3. You see, this one a 2 and a 2, a 4 and a -1, a -2 and a 5. So you have that second, the new second row. And for your R3, you are going to get rid of this 1. So you are going to multiply your R1 by the opposite number here, which is -1. So it means that you simply do R3 minus R1, right? So your R3 go first, and then let it minus the each element in your R1. So 1 minus 1 is 0. 1 minus -2, you got a 3. 4 minus 1, you got another 3. Okay, so we are done for your first column. So you are going to sweep to your second column. Okay, and then look at the second position of your second column. It must be 1. It must be 1. This is not a 1, then you just divide by that number. So you divide by 3 or multiply by 1/3 of your R2. So your R1 are the same, your R3 are the same, only your R2 that is changed. So after you got the 1, you need to get rid of these, I mean all the numbers, okay, in that column. So it must be all 0. So now because you look at your still on your second column, so the fixed row that you are going to use as a common will be your R2. Okay, will be your R2, and then the one that will fixed will be again your R2, and all the thing that will change will be your R1 and R3. Okay, so this one you need to get rid of -2, so you are going to multiply opposite number to your R2, and then you do the add with your R1. Okay, so, and I mean, if you look at your second column, usually not usually, actually, I mean, that's all the time, that the first column will not change at all. Okay, so you are going to, you know, just copy your first column because it is already done. It will remain the same all the time. Okay, and then you can write down this 1011 first, so that you know that this one keep it fixed. Okay, so to get rid of this, okay, as we told you that you multiply your R2 by the opposite number, which is 2. So here you just work with the second position of your second row, right? So this is a 2, and then you add a -2. Of course, you have a 0. This is a 2, and then you add by 1, so you have a 3. And also you need to get rid of this 3, so you are going to multiply by the opposite number to your R2, which is -3. So you have -3, and then you add a 3, so you have 0. You got -3, you add another 3, you have a 0. And then you sweep to your last column, and then look at the last position of your last column and look for the one below if it is 0, right? But you don't have anything below, then it means that here you are done, and this one is already reduced. Okay, this one is already reduced. So how many unknown? You got 3 unknowns, so your n is 3. How many non-zero row? 1, 2, so your k is 2. So it is what? The k, it is strictly less than n, right? Your k is strictly less than n. So it means that you have infinitely many solutions. And yes, it is, because look at your first equation. It becomes x and 3y equals to 0, right? You see x and the 3y. And your second equation, it is y plus z equals to 0. So it means that here you have a common variable z. So it means that you can simply write your x in terms of -3z, and also your y in terms of -z. So usually we are going to say that if your z is any number r, okay, so r, it can be any real number, then your y, it will be -z, so it will be -r, and your x will be -3z, it will be -3r. Okay, or you can, I mean, it depends on what you like to do, and this is pretty natural, right? Sometimes you may say that, hey, can we do it this way? If your x is simply a real number s, okay, if your x is a real number s, just like this, what will be your z? Your z will be what? S over -3, right? S over -3 or -s over 3. And as you know your z, you know that your y is -z, so it is a negative of -s over 3. So it means that your negative is gone, right? Okay, and if you want to do it some other way, saying that, hey, why don't we let your y equals to a real number t? Okay, this is a real number s, this is a real number t. Then immediately, if your y is t, then your z is -t, right? Because it is -y. Okay, and as you know your z to be -3, your x, it is a -3z, so it is -3 multiplied by t, So you have a positive 3t as your answer. Okay, so you can write down your answer in several ways. Okay, depends on your z at the beginning, or depends on your x at the beginning, or depends on your y at the beginning. Okay, it will be the same, right?